Hi all, welcome back. I am Vishwanath. This video is a part of database series videos where earlier we have covered installation of SSMS, discuss on converting business requirements to various models like conceptual, logical, physical. Also we have converted these models into a database tables and we have discussed on various scripts like you creating a schema, creating tables and dropping the tables, and we have also seen like how we can use insert queries in order to insert the data by specifying a columns or without specifying columns by adding single rows or multiple rows. And also we have seen how we can use the select queries in order to retrieve one or more columns or specific columns or all columns or using column aliases or expressions. We have also discussed on min, max, count, average, sum, case, null if, distant, count, length, top, percentage, and where clause. We have also seen on order type how to use order type with other combinations and group by having duplicate offsets fetch. And in this video, let's deep dive into a discussions on alter statements and let's see like what constraints are like we have already seen like primary key, foreign key constraints and null constraints, but not the check constraints. We will try to cover constraints as part of alter statement, and we will also look into how to update the data or delete the data, truncate or drop the data, and see what is the difference between drop, delete, and truncate statements. Along with that, based on the time available, we will cover on joins, we like inner join, various joins like inner join, right join, left outer, cross, self, and as well as the sets. And we will also see what is the difference between union all in terms of performance and also in terms of retrieving the data, and intersection except CET, pivot, how to convert rows to columns using pivot, and also we will see on merge. Without any delay, let's get started. If we look into our design on because currently we are only discussing on address table. If we look into our address table, what we can see is our address table is not helping us to identify why this table is going to be modified, or who has created the records or modified the records or deleted the data. In order to hold that kind of information, which I call as an audit information, um, typically we need a couple more fields to be added. Like for example, who has modified it, then we need to have a field with the username, and when they have modified it, so we need to have one more field to say like the timestamp, and why did they modified it, so we need to have a field as a reason of change. Let's add those fields as part of our table, alter table, table, because we are dealing with a demo address. All I want to say is I want to add couple more fields. So my fields are username is what I want to add, and I want to add lock number, and I will talk about lock number in a minute. Reason or a reason for change, who has modified the data, and the fourth field that I want to add is the create timestamp. Create, instead of writing timestamp, I have mentioned as a TSP. It's not a teaspoon, but it's a timestamp. So the first one, username, the data type of the username I want to hold as 50. So I have just mentioned as a varchar 50, it can take up to 50 characters, and lock number, because it's an int, I mean number is an int type, so I want to mention it as an int. Why we need to have a lock number is that there can be a scenario where one record is being read by multiple people, and also at a point of time it can be um, modified by multiple people as well. In order to maintain like a data consistency, we need to have this particular field called as a lock number. Using this field, how we can achieve the lock number is very simple. Assuming that I have a data in my database and whose lock number is 5, which is read by two persons, A and B. Both the persons A and B are trying to modify the data. When they're trying to modify the data in the database, they submit a query which will have a lock number as well, where lock number equal to lock number plus 1. So assuming it is 5, 5 plus 1 is 6 in both the records. When A is trying to update it at the same time as a B, whichever query is being processed by the database, that will hold as a 6. So once it has processed, now the data will have a record of 6 in the database. And again, if someone is applying with the 6, which is a old record, data is uh, getting rejected. In that way, we can maintain data consistency, and hence we need a field as a lock number which is an int. And reason of change, as I mentioned earlier, we wanted to have a field, in order to know whether it is the record is created, where we can say like reason of change to be a. This typically a stands for created. Or you can also have this to be like int type, where you can say like 1 2 3, but in my view, I think like having it as a ABC will work as an update, and C as a delete. So, and timestamp, you can mention this to be a timestamp. uh, Timestamp, and let's give comma, and also let's have uh, equivalent one, where I'll just be mentioning why we should not mention it as a timestamp. And let me select all the fields first. Select this field first. So before running our query, let's see like what is there in the database, where we have existing fields. We have our 12 records in the database. When we are trying to add something, we can have these four fields, and we can select the data on the database, where you see the timestamp to be a funny number, which is not read by humans. So instead of having the timestamp in this format, we can go for a date timestamp too. Date time two, which will take like the format of 3. And also I can mention like for an existing records, I can mention like it is not null, where I when we are trying to say like for an existing records it is not null, we also have to mention like what is a default value. Because on the existing records it was not having it, so I'm trying to default it with the current timestamp value, current timestamp. So before that, now let's drop these columns, because I want to drop the columns. All I want to say is, okay, let me frame another query instead of modifying that, so that it will be read easily. Uh, so. So in order to modify, in order to make it as a drop, we will be saying as a drop columns. What is a column that we want to drop? We want to drop like a username, and you can also mention like if you want to run it for multiple times, where you can say like if exists only, just drop it. Uh, Using if exist statement, I personally prefer it so that you can run it multiple times. If column exists, probably I would have copied even this. We need not mention when we are dropping it, we need not mention the data type, and hence data type is not required. So that is the reason of flushing it out. So this is how we can create our drop queries. If you want to, drop some columns, we have to mention like a drop column explicitly. Uh, and in case of you are dropping multiple columns, you can give a comma separated and you can mention like the rest of the values. Let's drop all the columns what we have created, and also let's check whether the columns are being dropped or not. Yeah, perfectly it has dropped. And we are now going to create it with the default timestamp where I'm using like a create timestamp data type as date time 2, which will now you can see the results of it. If I run the execute query, now you see like the data is in now in a better presentable format, which is read by human eyes. So that is the reason instead of just saying as a timestamp, I just want to use like a date timestamp too as a data type for all timestamp fields, and that is a suggestible thing. And now we will also see like what if you want to drop this particular field, will the existing drop queries will work? Let's give it a try. So if I go and say I want to alter this table and I want to drop all the columns, you can see like there is a funny message saying like there is a dependency. So what it is trying to say is whenever you are trying to add statements where you are saying as a default, that's a constraint. So uh, based on our script, a constraint has been created, and the name of the constraint that was generated has this name. So if you want to, drop this particular column, you need to you can drop the remaining columns. So you can drop the remaining columns, but not the timestamp field. So you now we have dropped the remaining columns. If we run it again, you'll see only timestamp is remaining because timestamp has a dependency on the other column, how we have got that message as. So what we want to say is we want to drop a constraint, not the column, because it's a constraint which was auto-generated constraint. So the name of the constraint is this constraint. So we want to drop this constraint. So let's run this query, and sorry, it should not be my mistake. It should not be in uh, single quote. So it is a name of the column. So if I run it now, you see the command to be, successful. Now, if you want to run this, you can still run it, and all the columns are now dropped. Whichever the columns we have created as part of today, which are dropped successfully. And that is the reason, even if you have columns or not, if you run this query, it will not break if you have this statement as if exists. So that is the reason of saying like it is always a good practice to say like if exists, so that scripts will run without any issues. For now, let's create this column and run our statements. So that's how we have learned of how to create a like alter the table, and also using an alter table how we can add columns, columns or drop constraints that we have created as part of it. So the and we can also create a constraints with a check saying like if this is present, then only you make the data to be present, where we call that as a check constraints. So let's see a small demo on that. So let's see how we can add a constraint, because we have working with this alter table. I'll just copy that alter table, and I want to add a constraint. I want to discuss on check constraint, where I want to check my check will take typically expression, and the value inside that will check for length of address 1 is greater than 0. So anyway, we have mentioned this to be a not null. So um for demonstration purpose, I have used this field, and I'm trying to say as a valid address 1, the name of the constraint. So if I want to say like I want to create a constraint, valid address always while inserting the details, then probably I can say like address to be greater than, let us say, 5. Maybe 2 for easy for testing purpose. So if I run it, you can see like a constraint has created. Let's go to an insert statement where we have inserted a couple of addresses, and let's copy one among them, and let's see how we can use this constraint to insert the data on our first address. So if I say like L, only one character I have, it should be greater than 2. So if I'm trying to insert this query in the address table, you will get a message saying like valid address constraint, because it has not inserted this record. So if the length is 2, then you can see that the constraint is now satisfied and the data has now inserted. So if you want to retrieve the data, we can select the data by this clause, and we can see like this is our record, address 18. And if you want to delete this record, where we can say as delete, because we want to delete from this address table, we have to mention like what is the record that we are interested in deleting it. Instead of deleting all the data, if you don't supply the where clause, then all the data in the uh, table will be deleted. So never use delete without a where clause unless that's the requirement. So in those cases, instead of delete, you can go with the truncate table itself, where it will be more efficient way of purging the data. Over here, we want to purge the data where the data record is 16. So ID is 16. So if we run it, we can see that data is now deleted. And let's run if we have any, like data that holds the value of say, 16. CLE select star from. So in this way, we can identify whether the data is deleted or not. So there is no data which is related to the 16 in our table. So we didn't get that information. So this particular data, this is how we have added the constants. And let's see how we can drop the added constants, because so the constant that we have added is address one. So what we are trying to say is we want to drop constant as this. So that's how we have dropped the constant, uh, because we don't want to have that constraint now, where we have dropped it. So in that way we can use it. Also, if we want to default our values for log number, let us say we want to default the value this to 0, because it is an int, and because it's a character, we want to default this to value a whenever it is created. So we can still alter it. I have just dropped the columns, and I'm trying to run it again. Yeah, so columns are dropped, and let's alter this table where we can say like this is what we want. And if we run our table now, now we will see the data has populated for create timestamp. And you see the values are still null. That's because we have not mentioned it to be not null. So let's copy not null as well for other fields. In other fields, and let's have it not null, and we have to drop. uh, and while dropping it, it is a little tricky because now we have a constraint on each and every column, and it is going to be a dynamic every time. So these values we have to keep looking into the message, and then we have to keep adding those values. So if we go back to the record once again, if I say like a drop, you can just see that I still have a constraint on reason of change because we have not given the defined value. It's a system generated value. That's the reason this constraint is appearing to be different. You can explicitly mention like what is the value that you want to define as. Let's drop all the statements. We still have one more constraint on timestamp. Uh, once we drop all the constraints, we can also run this. Now we will see with the default values which are now having on the database. Let's quickly run the select statement. So if you run the select statement, now you see apart from username, the rest of the values are having good value saying like lock number is 0, which 0 stands for all our fresh data that are inserted, and anything other than lock number 0, like 1, 2, 3, 4, blah, 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 anything other than that, we can say like those are modified data. And for delete, we can have something as a -1, so that we will know that record is deleted. In that way, we can hold the transaction. And reason of change will for the delete will be B. If you don't want to touch upon the lock number, you can still have another field as a reason of change of B, and B for update and C for delete. So in that way, we can maintain it. And for any reason you have decided to change the schema of the table, then you can go with the alter statement. For example, alter. Uh, if I want to, like alter table, I'll just copy it, and I want to alter one of the columns. I think we have created a reason of change. Uh, so let me copy that. Name where we have defined this reason of column to be character, and if for a reason if I think like I want to set it to character 2, uh, or redefine the data type. This is the way in which I can redefine the data type. You can see that syntax is appearing to be wrong, as the reason is whenever you are using it, you are altering a column, so you have to mention like a word column, and if you run it again, now you see it is successful. Now this will take uh, two characters sticks instead of one. So let's see the schema of the table. In this SQL Server, there is no describe table, but we have something called as an explain store procedure help, sp underscore help. So we will execute that, and we will get that execute sp help store procedure help, where we want to define what is the structure of the table. So we can, I think I went wrong. Just give me a minute. Yeah, so in order to describe the table, we have to mention the table name in terms of a colon. So where you can see like the various information of the table, like what it contains and what are the foreign key constraints, the constraints that we have added, and various other information of the table. So this is how we can describe the table using like stored procedure help instead of typing a describe command in MS SQL workbench. So probably I'll just say this as describe table example, so that you can refer once I commit this particular file to the GitHub, you can refer by looking into these statements. So Now, let's see how we can update a specific row. Probably where I can say by using an update query. Let's see how we can update it. In order to update it, we have to say like update table name where the update has to takes place. So I'm just trying to copy this. So because I'm trying to update the query, I'm trying to say like update this table. So what I want to update is I want to update a set of columns. So I'm trying to say like I want to update like address for example, I want to update my address for column to like updated value. This is the value that I want to put updated value. So if I want to set this particular updated value, you can pass n number of columns by saying as even my address 3 wherever I have my somewhere I just wanted to update like two columns so that you can refer like multiple updates how you can do it. So which will be comma separated. And now I'm going to say like what is the condition where it matches the data to be updated. So I want to update where my address 4 is null, address 4 is null. So whenever my address 4 is null and my address 3 is anywhere and address 3 value is anywhere. So if I run this query, uh, we will also have like select star from this update demo just to see what is the where condition for this operations before the data modifying. So we will just copy this where clause. So we will run this query so that we'll see like this is the data before modification, because now we are trying to modify the data. It is always a good practice that we set the lock number as well because we are trying to modify the data. So we set the lock number equal to lock number plus 1. So whichever the value that lock number is holding, we are incrementing that by 1 based on our update. And we are also setting like a reason for change uh, to be modified, which will take the value as a B. So, and we will also say, I mean, timestamp anyway, it will be uh, also have to be modified. So we are just saying as a current timestamp, it's not the request ID, current timestamp. So and yeah, and username you can set who is modifying it. So username I'll just set as my name. So these are the fields typically we want to maintain why the record is going to be modified, when, who is modifying it, when is it modified. And now let's run this query. So if we run it, we now the rows has been affected are 4. Let's see like what was earlier, and now we are not getting this data because the data has now been modified. So in order to see the entire results, You can just run this query again. Now you can see like all the data what we have created has now having the data as my other name, and the reason of change is B. Because in this exercise what we have seen is how we can update the data, and we have lost the initial data. In order to maintain the initial data, where we call it as tables, where we can classify the tables as base tables or and also history tables, so that the existing data is copied down to the history, and we can retrieve the information from the history. Let's see how we can do that. uh, as I said, like we can use select statement to create another table. uh, what you have heard is right. We will be using select statement to create another table, and we call this as select into another table, where I want to exactly replicate my table. Generally, this will be the first statement when we define any table, and we are appending h to it, where we'll say as a history table, or you can also say as a hyphen h, so that you can segregate it properly. And when I say as a copy this table, what we are doing over here is we are trying to select all the records and create a new table called history table of our demo from this table. So when we run this query, we will see like 12 records are being included, and when we describe the table, this will not copy the constraints. What I meant was, so if I describe my primary table, uh, or the base table, where you will have details on what is primary key. So you can see like first set contains like what is the information on the table. Second set talks about identity, what is my primary key on it. And also, if I have any constraints, it was mentioning like what are the constraints involved in it. If I run a similar query on my newly created table, I will not have all these constraints, where sorry, I think it is underscore h. So if I run on this particular table, you will not have any of those things apart from the skeleton of the table, which will not talk about primary key, foreign key constraints, or null constraints, or anything, but it just copies all the columns itself, which is what we also want. B- and in terms of uh, now that the table is copied, every time when we want to push this record, it is always advisable that the initial records are pushed to another table in such a way that we can hold the data. So we can frame a join, and we can view the data into. Let's see that in action. Let's take the same records which were modified, where now both the records are going to have like updated information. Like address 3 is going to have as an updated information. So if I run this query, I'll get what are the data that has modified it, and now updated value again, assuming that this is the value that I want to update it. Before updating, I want to preserve this values. So how I will be doing is that uh, I'll copy the current value to my history table, and then the existing value will be updated. So my history table initially will not have any data. So I'll be, deleting that table. Uh, Delete table, and I'll just mention my demo history table. I just want to, delete it. Deleting will just clear all the data, and when I say like drop, drop will basically, So drop will eventually drop the table, delete table, and the syntax I think I have missed. Delete from table, just like select star from table, delete from table. So if I delete from this table, uh, I think delete from is a clause, not the table. My apologies. So delete from this table name. Now the data is not copied. Ideally, when you want to modify the data, what we have to do is we have to copy the existing data to the history table and then modify this record so that when you frame a view of it, you will be able to see like what was earlier and what was modified. So. Just like how we have select star into, likewise we have insert into. So for this query, like these are the four records that we are interested in. So we will just say like insert into this table, history table from this table, and we will insert it. So I have just added insert into this command. So it is a combination of, so our statement will be like this, where the first set will give our four records, and those four records will be inserted into this particular table. So if I run this, and if I run my select statement on my table, select star from, so select star from history table. If I run this query, initially the data was not present. Now if I rerun it, so let's run this query. So insert into history. Let's run our select query first, where we'll see like the data was not even set. So if I fire this query, we are getting the same message. So now we have seen that we are getting this identity issue. So the workaround for this is there are various solutions, but the easiest and quickest solution is to use union all statement, where we will be clubbing as a select top one star from that particular statement. So it will typically looks like union all. I'll be covering the union all either in this video or in next video. Top one, I'm just saying like I want like a first record from my table, where my table is my address initial table. But if you look into the where condition, it will be very funny, where I'll be saying as 1 equal to 0, which means that typically I am trying to say like I don't want to have any record. So let me run this query. So I'm trying to create the table by selecting the details. Now it has created the table, and I'm deleting the records. And if I select the record, you see there is no data. But now if I am trying to insert the details, you see like four records are being inserted. Let me select the details which is there in history table. So in my history table, if I run it, you see like four records where the reason of change is B. Now we are again going to run this table. So if I run the values of this table, where it is going to have as an update. So where address is going to have an update. That is what our condition is. And if I run it, now you see 4 rows in my primary table has been modified. So if I want to know the results of both my primary table and secondary table, I can form as a view where we call as a join between the current table and history table, where I can also, quickly demonstrate it, but I'll definitely be covering those things little later, where I can talk about views and joins little later. So for now, how it will be looking like is that select star from live table, where I'll just say as this table, and I'm going to say like I want all the records from my history table as well. And I am going to mention my condition. I am looking for this records. So I'll just copy this condition. So I yeah, brackets are yeah. If we run this query, now we will see that what is the value. For example, if I run my first query, because there is no updated value, it has modified as an updated values now. So that was the reason I initially got like 4 records. But in my history, I have that as a updated value as a 4. So now, if you see it, now I'm getting the record. For example, if you look at address ID as 6, if you take a individual record instead of this, if I just change my clause where clause to contain like my individual records, saying as an address ID underscore to be a 4, sorry, underscore to be a 6 initially. If I take that particular record, and if I want to see like what was the initial value and what is the current value, how it was evolved. Now you can see like initial value is 1 and current value is 2, and you can see like how it has changed. So that is a beauty of creating this kind of views, where we say like a view is a combination of it is not existing as a table in the database, but we are still able to get the views. So i- uh, in this video, I'll be stopping it now, and remaining part we will be discussing in next video, where we'll be covering on truncate drop and rest of the statements. So what we have learned in this videos is basically how to alter the table, and where we can inject various columns, or we can drop various columns at once, or we can add or remove constraints. And also we have seen like how we can use execute procedures, in order to describe a table. And if you want to update it, what is the best way of updating the table by creating like a uh, temporary, or we can say as a history table, where the schema of the original table is copied. And in order to hack the identity, we have also gone ahead and joined with the unions, which I will be covering it in next video. And we have also flushed the data. We don't want to copy that with any data. So probably we can just say where 1 equal to 0 inside this clause itself. Uh, so and once the this particular insert has taken place, whichever the values that we are trying to modify, then this clause is going to be same as this clause in the update clause. So we have seen the update clause as well, and then we have also covered delete statements. Thanks for watching. I'll meet you in the next video.